Good morning, class, and welcome to this lesson on momentum 3. Today we will be able to define the conservation of linear momentum and apply it in equation form. So today is about conservation of linear momentum and how do we use that in an equation. So let's define that first. Conservation of momentum. The total momentum of an isolated system this means no external forces, no net external forces are acting on this system, okay? This remains constant. This concept of conservation should be familiar to you because you're already used to conservation. You're already used to conservation of energy. And so now we're just going to apply the same thing to conservation of momentum. Or essentially, the momentum initially equals the momentum finally. So the initial momentum will equal the final momentum in a given state that has no net external forces acting on the system. Okay? So when it comes to this, we very typically are always going to be dealing with two objects. Okay, two objects are going to be coming together or moving apart in some sort of way. So when it comes to this, we have initial momentum and final momentum. Well, we can really expand this out in the sense that we have two objects, okay? So we have m1 v1 plus m2 v2. Now I'm going to go back and put the letters I there. This is my initial momentum equals my final momentum. m1 v1 final plus m2 v2 final. I got to tell you, I mean, we have 8 terms here. We have 8 terms here in this whole thing. It is very, very easy. It is very, very easy to put the wrong number in the wrong spot. So I strongly suggest when you have a word problem that is written out, that when you go through, you are circling all the values and you are identifying this is V1 initial, this is V2 final, etc. Okay, so because it is very, very easy to mess these problems up just because of bookkeeping. So it is very important that you slow down, slow down, and write things out and make sure you have the correct labels, because more than likely this is actually simple math. We have two values, we multiply them, we add them together. This is very simple math, but the issue is making sure the right number's in the right spot, because every problem is a word problem. And with every word problem, we have to identify certain things and make sure they're in the correct spot. And it's easy to get in our head and mix up M1 and M2 or whatever. Okay, so that is our equation. Okay, now I'm just going to go through a couple simple things to give you an idea. I'm not going to do any word problems. I'm not going to do any numbers. I'm just going to do equations for now, because you do have homework assignments and you can do the problems there applying this knowledge here. Okay, so I highly recommend when you do this kind of things, you draw pictures. And with momentum, we typically want to do before and after pictures, okay? Because it is very simple to mix up what's going on. So we do before and after. So let's say in this situation, object 2 at rest. So we have an object like a billiard ball or whatever, and object 2 is at rest. And afterwards these objects hit, and then they are both moving to the right as seen here. So before we have velocity 0, here we have both are moving to the right, but you can tell from the picture kind of this one's moving faster than that one. So when it comes to these pictures, it's going to help us define. I'm going to look at these pictures and say, okay, here's my XY coordinate system. Everything is moving to the right. It's going to be better for me to make a plus sign going to the right because it makes my math easier. Okay? So in this situation here, we would do m1 v1 initial plus m2 v2 initial equals m1 v1 final plus m2 v2 final. And I'm going to call this, I'm going to call the ball that's coming up first object 1. This is object 2. And so wherever it says m1 v1, I'm always talking about object 1, and m2 v2, I'm talking about object 2. This is 2 1 2 1. So like I said, it's very easy. All I'm teaching right now is to be clear and concise what you do. Don't try to jam it all into one spot or try to work it out very quickly, because it's very easy to mix up your numbers and mess up the equation down here. So in this situation right here, object 1 is positive, so I'm going to have a positive velocity. This one has a 0 velocity, so this term cancels out. This one over here has a positive velocity. This one over here has a positive velocity. And so I know that I'm going to plug my numbers in here. And let's say I was solving for the final velocity of object 2. Plug in all the correct numbers, subtract this one over to that side, and divide by m. So I mean, this is all basic algebra that you're very used to. So this is just a simple situation showing you two things colliding. Momentum is conserved. Momentum initial equals momentum final. The net momentum of these two combined is going to be equal for both of them together. So just another simple example here. Let's say two objects approaching. Two objects approaching each other. So we are going to have this ball coming this way, this ball coming this way. This is before, after. Okay? They're coming together, they hit, they go apart. Object 1, object 2, object 1, object 2. Same thing, that's plus. Okay? I'm going to call it to the right positive. Therefore, object 1 is positive, object 2 is negative velocity. Object 1 is positive, object 2 is negative velocity. So if I was going to write this out, I would do m1 v1 initial, that's being a positive number, and then I would subtract m2 v2 initial, because this is negative. Maybe if I mess you up, I would do positive m2 negative v2 initial. That's where I get this negative from, because if I minus it here or minus it there, it doesn't really matter. Okay? So these two are going to equal to a negative m1 v1 initial. Why? Because this object is now moving to the left, plus moving to the right, final m2 v2 final. So this would be a way to set it up, making sure, because in a problem, it's not going to say it has a negative and positive velocity. It's going to say two objects are coming at each other. And if they're coming at each other, then you need to define, okay, I'm going to call this positive. I'll call that one positive, this one negative. Now everything's set straight. Okay? So that is it for conservation of momentum, setting up the equations pretty simply.